Yes. So I would make sure that you guys are trying some of that on your own. Thou shalt not forget, 59 out of 60 has not been beaten yet. So 59 out of 60 is a current high score. Someone in this class owns that. Well, we don't know.
What did I tell you? Nothing. Oh, you can't just do that. You can't just, I remember something.
Unit Quattro.
What is it? Is it about Saturday? Oh, okay.
All right, here we go. Chemical reactions. How would you know if a chemical change has occurred? What would be evidence for a chemical change?
Color, light, heat, smell, precipitate.
Heat, light, precipitate, color, smell. What else? I'm thinking of at least one more big one.
Gas.
Bubbles. Or formation of a gas. Explain the difference between chemical and physical changes. Well,
Wait, what does that say?
Reversible
Heat.
versus non.
No, because
Ooh, I like that.
they're non-reversible.
chemical changes.
Actually change the alignment of atoms.
Chemical is a rearrangement, let's say that, of atoms. In other words, something new is made. I like the reversible and irreversible too. I mean, a physical change, you can usually, well, I don't know. I guess if you rip a piece of paper, you can't. It keeps the same properties in the physical change. So a rearrangement of atoms, something new is formed. Okay. Place the following changes in the correct column on the following table. What would be a physical change?
Cutting people.
Cut paper. Another physical change. Chop the wood. Another physical change. Melting cheese. It's still cheese. I know, my stomach just rumbled. Last one.
Like chewing food.
Chewing food. Chewing food just breaks it up into smaller pieces. So your chemical are burning paper. Burning paper, you're going to have fruit rotting. Why does it just sound gross? You ever have like a piece of fruit in your fruit basket go bad?
Yeah.
And you got like gnats in your house? Tis the season. Tis the season. Digesting food. And the last one is going to be grilling burgers. My brother just got a Blackstone and it's bigger than mine and I'm so jealous. It's really nice.
Someone had an air fryer built in.
What?
I know. It was like
JK, that's Jack.
Dude,
Yeah.
the disrespect.
That's how he writes his name on all of his papers now. Place the list of changes in the correct column on the following table. Physical change. What would be the first physical change? Vaporizing. Because I can get it back. What else?
Distillation? Wait.
Yes.
Oh, yeah.
Yeah, it is.
Yeah.
It's distillation.
Distillation would be one.
You guys have me scared.
And which the third one? No.
It's sublimation.
Sublimation. My chemical changes are rusting, because you can't get it back, combusting, and then electrolysis.
Rusting, combusting.
Rusting, combusting, and electrolysis. Flip the page. So electrolysis is where you're hooking up an electrode to water with a chemical, and it breaks it back up into hydrogen and oxygen. So you can't get it back unless you would electrify it again, which is not, it's a permanent change unless you would do something, yeah. Okay, flip the page. Here we go. In your own words, what does conservation of mass mean in a chemical reaction?
Not be created or destroyed.
I love that. Cannot be created or destroyed, which is not really your own words, but there's not really a better way to put that.
I've been learning it like that for like 5 years now.
Probably longer than that, right?
Wow. Well, I mean, I didn't like my in 6th grade.
You begin a chemical reaction by mixing 5 grams of substance A with 3 grams of substance B. There is smoke and fire. a new substance is formed, which we will call C. You weigh substance C and find that it is 7.5 grams. What happened to the missing 0.5 grams? Went to the smoke. Went to the smoke. Choose any real-world physical change. Write the change as a reaction.
Ooh. Can we just boil water? Is that what it is? Oh, physical change.
We're gonna burn water.
Physical change, like
That would work.
water solid to water.
Water to water vapor. You guys are so creative.
I was thinking of throwing a desk.
Throwing a desk?
You're like a physical change, and I was like, I don't know, you just like.
I mean, I guess if the desk broke or bent.
Yeah, I don't know why.
Aubrey's-
Desk right
I
side
thought
up,
you meant you were
desk
like
sideways.
considering throwing a desk.
Oh,
right
no,
now.
no.
Create the equation for these two changes include states of matter. Dry ice sublimates.
That's CO2 solid.
CO2 solid is going to CO2 gas. Ethanol undergoes combustion. This is a little more complicated. C2H5OH plus what?
H2O.
O2 yields CO2 plus H2O.
Bruh.
Got to balance.
No, I'm not doing all that.
So two C's, so it's going to go in front of this C. Two. I have 6 H's, so it's going to go in front of this H. 3. 2 times 2 is 4. 4 plus 3 is 7. I already have 1 here, so what's going to go here? 3.
I hate math.
You're measuring the process of cellular respiration. You find every glucose molecule is burned using 6 molecules of oxygen to make carbon dioxide and water. How many carbon dioxide and water molecules are made? Show your answer writing the balanced equation. Okay, well that's easy. C6H12O6 plus O2 yields CO2 plus H2O. You find that every glucose molecule is burned using 6 molecules of oxygen
No, it's easy.
to make carbon dioxide and water. So, in order to balance this, it's going to be 6. This is just what? Well, photosynthesis makes the sugar. Right. And then this is using the sugar, essentially.
Like reverse those.
Kind of. Flip the page. Following represent reaction of oxygen.
Bruh. Are you
Brother.
Physical change.
Get it? Oh my god.
We just had a massive coffee spill.
Hungry.
Nothing got on the sweater. I think we are okay.
Go back and like, oh, whatever.
Did anything get on your paper?
No, making Jack do it.
Wow.
I still.
Yeah, but he still got paper towel. That was kind. Jolly should scan the card for that.
I'm a reward man.
For helping clean up, that was B. What is that?
I'm like one of those.
Respect, integrity, safety, or engagement. What would you guys call that? Safety. There you go.
Ooh, I know what I said.
Whatever.
What else do you want on your t-shirt? It's gonna be a pictures. It's wonderful.
We have Clementines on there. Chem's giving. Did it get on anyone's shirt?
We should put
Oh, this is my mom's study, so she would look.
Oh yeah, we should put
You guys are
Dr. Mole.
Yeah.
what?
Like Dr. Mole box.
Oh yes, that was so cute. That was so cute. All right,
I'm never gonna get over it.
that was hilarious. Physical change. Who yelled that? That was awesome. That was really funny. The following equations. The following equations represent the reaction of aqueous sodium phosphate reacting with the calcium nitrate solution. Label each type of equation: molecular, complete ionic, or net ionic. So, what's the first one? This is net ionic. Molecular is like your regular balance equation. So the next one is molecular.
I love the way sodium is literally always a thing.
And then what's the next one? How do I know it's complete?
Because it's complete.
Everything broken up.
It includes the spectators. It includes the spectators.
Sodium and nitrate always being spectators is the funniest thing. It's like never are they.
Okay, I want you guys to take 3 minutes and do it. Lead 2 nitrate is combined with salt water. Write your balanced equation, your complete ionic, your net ionic.
Bruh. Nitrate's NO3, right?
Yep.
Okay, NO3. Instead of NO3, it's a -1 charge.
Is that the NaCl and H2O?
Is this
It's just going to be NaCl, AQ. It's aqueous, so it's NaCl, AQ.
Unifor due tomorrow?
Unifor, I don't care.
Oh,
You can either turn it in tomorrow or turn it in Monday with 5 and 6. Either one's okay with me. It's only going to be like 25 minutes worth of video to watch tonight, so. Either one's okay with me. By Monday.
Guys, I think NaNO3
is
is.
lead nitrate aqueous?
Is what aqueous?
Lead nitrate?
Yes. It says lead 2 nitrate solution.
Oh, true.
I think that sodium nitrate is the precipitator.
Really?
You do not.
Wait, NaNO3? Oh, okay. I was going to say.
Alkalis are soluble and
I'm-
nitrates are soluble. Together it's super duper soluble. I'm going to Skyline Chili with the Sky Guys tonight. So we have a group of 7 of us guys that go to Skyline Chili every like so often.
Oh, you should never.
So the water
We-
Chili is the most important thing ever to exist.
You know,
And I've had some,
you can have that opinion.
I've never had it, but I don't like chili.
We don't need states in the.
They're just.
You don't have to do states, they're just helpful. I'm going to start my work while you guys are doing yours, so don't look at mine.
Wait, water is going to be complete.
It's not.
Yeah. Alright.
Salt water just means it's NaCl AQ.
They have a menu item in Skyline Chili called the fruit zone, so weird.
We don't stop talking.
It's weird.
Shh.
Shots fired.
Oh, why did I write NaOH instead of Aqueous salt water.
We're getting a basic
NaOH.
solution of this one.
What else do you want to share?
So the first one is for balancing. Stoic. The complete ionic shows all ions. The net ionic shows only ions that form the product. And how would you describe a spectator ion?
There's no like a thing.
It's in solution of those.
Yeah, the ions don't precipitate or they're not affecting the end outcome. How can we check our answer? What is 2 positive plus 2 negative? 0. 0 equals 0. So it should balance, should be balanced, and your charges should be the same. Net ionic equations. Are we feeling, we've done a few now, the last week or so. Are we feeling a little more confident on these? Other things to think about net ionic equations. Strong acids completely dissociate. Weak acids stay together. H2O liquid stays together. So don't forget about that with your net ionic equations. Can I flip the page?
There's a lot of empty boxes on that page.
Can I flip? Okay. Okay. Oh man, particle diagrams. Okay.
I swear I'm done.
C3H8 plus O2 yields CO2 plus H2O. 3 C's, 3 C's, 8 H's, 8 H's. What's going to go on my O2? What coefficient? Which I did not leave myself enough room for.
6 plus 4 is 5?
5.
Yeah.
And now we're supposed to draw our particle diagram for the reaction. Okay. Well, 5 O2s, so it's going to be 1, 2, 3, 4, 5 diatomic. C3H8. 1. There's my 3 carbons, right? So let's just draw our hydrogen small. We know that CO2 is going to be like this. And we know what water looks like. Mickey Mouse.
What do you think oxygen's equal to?
I'm not drawing this to scale. I feel pretty good about writing out equations. Do we need to do another one, or can we keep going?
No, I'm not doing all that.
Okay. Could you do nitrogen gas and hydrogen gas react to form ammonia? That would be N2 plus what? Plus H2 gives me what? NH3. And then to balance that, it would be 2, 3. Yes? Okay. All right, good. Complete the following by adding a less than, greater than, or equal to indicate the atom pair is larger, smaller, or the same size. Oxygen atom, carbon atom. Why?
More charge.
More protons.
Same shielding, but a greater number of protons, so there's a greater core charge.
Yes. So, oxygen has technically more electrons, right? But the nuclear charge in oxygen is what? Oxygen has a higher what? Core charge. So, pulls in electrons more. Oxygen atom and O2, oxygen atom and H2O. You gotta think about this one a little bit.
Oxygen and H2O.
Which one's gonna, what am I writing here? Less than, greater than, equal to? Why?
Okay, because oxygen has a greater electronegativity than hydrogen, and so when it is in a molecule with H2O, it pulls the electrons over to it a lot more, and that electron cloud makes it bigger. But when it's just O2 that has the exact same electronegativity, so they share the electrons.
That's true, but also shorter the length,
Oh, well, I overdone this.
stronger the strength, right? What type of bond do I have in O2? That's a double bond. And this is a single bond. Or you could say an H2O oxygen is hogging the electrons, right? O2 is a double bond, which is shorter than the single bond in water.
And why does that shorter bond make it smaller?
The shorter the length, the double bond.
Yeah, why does it make
Because remember, in order to get 2, it was like this. And 1 is like this. 1 is straight apart, 2 is like this. Na plus or Ne?
Wait, which one's smaller? I think the NA is smaller.
Yeah, I agree.
I guess there's 3 levels of shielding, but
No, but
It
it
loses
is
electrons, so
they're
they're both.
they're equal.
They're equal.
The equal.
What has Na plus done with an electron? Lost one.
What's the proton?
It doesn't matter.
Doesn't matter.
It's the same shielding.
It's still the same shielding. Once I've lost an electron, it's basically the same. Flip it. How many pages do we have left? 1, 2, 3, 4, 5, 6, 7, 8, 9. We got to keep going. Okay. Students performed an experiment where they measured the mass of a ball of steel wool and found it to be 4.6 grams. Then heated the sample in a flame for 5 minutes, making sure to heat evenly on all sides. After allowing the wool to cool completely, the students took the mass again and found the new mass was 5.1. What caused this change in mass?
reaction.
Oxygen, right? Oxygen from the air did what? Reacted. To make, what was made? Iron oxide. Essentially, creating rust, right? So that's the increase in mass. Oh my gosh.
Can I see the word particle diagram one more time?
All right, let's do it. So let's draw sodium cube.
Sodium cube.
Negative, positive. Let's try to make our negatives a little bit bigger. Positive. Trying to do our lattice structure. I'll do 3 rows for funsies. So before, what are my water molecules going to be doing? Just floating around, right? Yes? What about after? I'm not going to follow the law of conservation of matter drill on this, by the way.
They're going to be
Sodium does what? Breaks up. So
it's going to be interacting on the ion.
this negative is going to have the positive side of water towards it, right? And the positive is going to have the what side of water towards it? The more negative side. I did not draw that to scale very well at all. You got it. You and your lab partner are in an intense argument. You attest strongly that dissolving NaCl in water is a physical change, while your partner is adamant this is a chemical change. Lay out the argument for both sides. Why is this a physical change?
As soon as the water evaporates off.
Nothing new is made.
What is the evidence for it being a chemical change?
Well, I'm asking you guys.
Changes properties, right? Because bonds.
Ionic bonds are what? Broken.
Oh wait, what is?
This would be ionic, right? What is the new type of bond being formed? Ion dipole. So new ion dipole are made. Ionic bonds are broken, new ion dipole are made.
Wait, so is it physical or chemical?
It's physical. It's physical. You can have a change in intermolecular forces and still have the same thing. Flip it. Okay.
Is this? Wait, can I?
How did you know?
Because I saw volume, I saw pressure, and I saw temperature.
You got it. I got a volume, I have a temperature, and I have a pressure.
And I also saw mass and pressure.
Solving for a mass. So I know that PV equals nRT. Agreed? If I'm solving for mass, I'm solving for what letter? So N equals PV over RT.
760.
So N equals
Why would they make it 758?
0.99, it's 0.997, I'll just tell you. ATM, because you have to convert to ATM, right? So 758 divided by 760 is 0.997 times the volume, which is 8.75 liters, over R, which is 0.0821
821 or 8206?
06 liters times atmospheres over moles times Kelvin times T. What's 37 plus 273? 310 Kelvin. 310 Kelvin. So solve for N. Tell me what you get. What'd you get? Point 343 moles of what?
C8H18. It should be C6 because it's 37.
Okay, that's what I have.
Moles of C8H18.
No, you can get green.
Oh, yeah.
It's asking for what mass of carbon dioxide. Oh shoot. That means we have to do what?
Are you for real?
We gotta balance the equation first,
Oh.
right?
Oh, I'm gonna throw myself.
So C8H18 plus O2 yields CO2 plus H2O. It's going to be 8C. Oh wait, hold on. I have 8 C's.
9 on the water.
If I put a 9 here, but think about that.
Double everything.
You're gonna have to do it. It's gonna be a double. So it's gonna be 18, which means this is gonna be 6, this is gonna be 2, and this is gonna be 15. Because once you have to put that 9. Now I can do it.
Why was there an 8? Shouldn't be 16 on that CO2.
On the what?
On CO2.
6 C's. Yeah, you're right. 32. Wait a second. 12. 6 C's.
Because there's 16 C's on the outside.
Oh, you're right. 16. 16 times 2 is 32. 32 plus 18 is
A lot.
50. So this shouldn't be 15. That should be 25. There we go. That's better. So now I can do my stoic. Be 16 because 2 times 8 is 16. So I'm going to take my 0.343 moles of C8H18 for every 2 moles of C8H18. I have 16 moles of CO2. And for every 1 mole of CO2,
44.009.
I have 44.009 grams of CO2. What are we going to get from that?
Wait, how many C6? Oh, 120.
0.343 times 16 times 44.09 divided by 2. What'd you get?
120.
Why do I have 120,000? I typed something wrong. 0.3,
I don't think that's
0.343. Oh, it's because I did negative
similar.
instead of that.
I respect your prowess, but it-
Divided by 2. Yeah, I got 120. So I have 120 grams of CO2. 120 grams of CO2. Okay. Given the following equation, list all possible mole ratios for reactants products. The first is given for example. So for AL2, do we need to do this? We know mole ratios, right? Okay.
no.
What mass of aluminum sulfate can be produced with 2.76 grams of aluminum oxide? Are we good with stoic? Can we keep going?
Yeah.
Okay. Let's keep going. So more stoic.
Oh, no, it's one of these.
You know what? I'll throw this up here in case I'm just gonna put it here for the recording.
I'm just thinking.
In case people, it's gonna be on the recording,
Oh, never mind.
But if you want to take a picture, you can. So there's the first one. Here's the second one. Here's some more stoic. We're not going to be doing basic stoic.
Aubrey. Aubrey.
Okay. Let's do this, and then I think we'll be ready to stop. A student conducted an experiment in which they added drops of acetic acid. I'm down here in the middle now. Down here in the middle. To 4.76 grams of sodium bicarbonate until no more bubbles were produced. The initial and final measurements of the entire setup are included in the table below. What is the student's theoretical yield of CO2 gas produced? What was the student's actual yield? What was the student's percent yield? So we have to remember how to do this.
I know.
So
Actually, sort of. Yeah, no, I do.
my actual yield of CO2 gas. So my mass before and my mass after. What am I going to do here? Subtract. What's that going to give you? Come on.
This is where I'm gonna miss points on the AP.
1.57 grams. Theoretical yield? Well, I'm going to have to write a balanced equation real quick. So acetic acid, HC2, H3O2.
All the weak acid problems always have acetic acid.
It's just what they like to do because it's easy to balance, easy to write. Sodium bicarbonate is NaHCO3 yields CO2 plus NaC2H3O2 plus water. To balance that is balanced. So theoretical, in theory, I'm going to start out with 4.76 grams of NaHCO3 times molar mass of that is 84.008 grams of NaHCO3 for every 1 mole of NaHCO3. Stoic step, every 1 mole of NaHCO3 gives me 1 mole of CO2, and 1 mole of CO2 is still 44.009 grams of CO2. So that will give me my grams of CO2 produced in theory.
What's this 84.008 grams for the molar mass?
84.008. So what do you guys get here? .49 grams CO2 in theory. So percent yield, right, is actual over theoretical times 100. So that's going to be 1.57 divided by 2.49 times 100. What do you get?
63%.
63%. What are 2 possible sources of air? What was I forming here? Why do I have my percent yield? Why is it low? How could I have lost CO2 gas?
It wasn't sealed.
Okay, so I could have lost bubbles, right? So loss of gas bubbles. Anything else?
Was it fully combustible?
Impure. Impure NaHCO3. Those would be 2 pretty good sources of air. So 1, 2, 3, 4, 5. That's perfect. We'll stop there.